Hello, pre-calculus students, and welcome to the continuing lesson on behavior of higher order polynomials. And in this video, we are going to explore key concept number 2, which states that finding zeros in multiplicity allows you to accurately draw bumps and grooves. So what we did in the last video was talk about end behavior, what happens at the extreme values. We ignored what happened in these little parts right here, and that's what we're going to explore in this video. So zeros here, just to make sure we're all firm on the definition. Zero here just basically means x-intercepts. And so the first thing we're going to say is that if the multiplicity is even, then at the x-axis, and this is certainly not a formal vocabulary word, but it helps to capture the idea. What it's going to do, it's going to kiss the axis. So let's say you had a function, a graph, and the multiplicity was even, and this was your x-intercept, okay, or your one of the zeros. So that means it's going to go down, is going to touch it, and then bounce back up. Or it might do something like this. If that was your zero, it might come from the other direction. It might come up, touch it, and it has to come back down. Okay. Now, if you have something that has odd multiplicity, then it's going to cross the x-axis. So if it was a zero with an odd multiplicity, and let's say this was your zero, the graph will approach it, touch it, and then keep on going. Okay. Same thing if you were to have that same 0 point right here. It might come from the other direction, come up, touch it, and then keep on going. Okay. And so these two ideas of odd and even multiplicity will be very helpful to us as we try to analyze these functions. And I know this is a little bit abstract at this point, but keep these notes with you, keep them handy for the next couple videos as we are going to do some examples with this. Now we're also, let me introduce, or this is really just a review. Key concept number 3, substitute for zero for x to find the y-intercept, where the graph crosses the y-axis. Okay, so for example, this just means if I have a function f of x equals x to the third plus 8x minus 7, the y-intercept is just f of 0, which gives me 0 plus 0 minus 7, which is negative 7. Okay, so that's all this concept is really saying. Okay. All right, so I'm going to end this video here, and you can kind of preview that we're going to get into some good examples here, and then we're going to see how all of these concepts connect and relate together.